Alright, today we are going to go over the Unit 7 benchmark review. You can follow along with me or skip ahead to check to see if your solutions are correct. Just remember your test is going to be 22 questions. Your review is 22 questions, so there should be some parallel there. So looking at problem number 1, it says given that AC is perpendicular to BD. Okay, so AC perpendicular to BD means that we are going to form a right angle there, and it also tells me that angle BAC is congruent to angle DAC, so those two angles are congruent. So as you can see, we are going to end up having two angles here congruent, so keep that in mind when we go to prove that the two triangles are congruent. So first thing I want to do is write down my givens. So AC is perpendicular to BD, and angle BAC is congruent to angle DAC. Reason being is it was given. Okay. Next thing that I'm going to talk about is I want to talk about specifically that angle ACB is a right angle. So I'm going to say angle ACB and angle ACD are right angles. The reason for that is it's the definition of perpendicular. And now that I know that they are perpendicular, I can say that they are congruent because all right angles are congruent. So angle ACB congruent to angle ACD because the definition of right angles. Okay, so now I know that I have an angle congruent and angle congruent. The next thing that I'm going to talk about is this line being congruent to itself. So I have AC congruent to AC, and that is an example of the reflexive property. And then finally I can say that the two triangles are congruent because I have an angle, a side, and an angle. So step 5, triangle ABC congruent to triangle ADC, and the reason being here is angle, side, angle. Okay, looking at problem number 2, it says complete a proof given the following information. So they tell me that segment GJ is congruent to segment GM. GK bisects angle JGM. So when it bisects, that means that these two angles are congruent. So we will have to talk about that right now. It just is implying that. So first thing I want to write down is my given, GJ congruent to GM, and GK bisects angle JGM. Reason being, given. Okay, so then next I'm going to talk about angle JGK being congruent to angle MGK, and the reason for that is the definition of angle bisector. So now I have a side congruent and I have an angle congruent. The next thing that I'm going to talk about is this line being congruent to itself because of the reflexive property. So GK congruent to GK, and again that is the reflexive property. So now I can say that the two triangles are congruent because I have a side, an angle, and a side. So triangle JGK congruent to triangle MGK, and the reason being is side, angle, side. However, look at my proof statement. They want me to prove that JK is congruent to MK. Well, now that I've proven that the two triangles are congruent, every other part is congruent. So angle J congruent to angle M, angle MKG congruent to JKG, and JK congruent to MK. So I can say segment JK congruent to segment MK, and the reason here is because we have the definition of congruent triangles. Going on to problem number 3, it says, how are these triangles congruent? So notice I have HI congruent to FI, I have FI congruent to KI. Don't forget about your vertical angles. So now I have a side, an angle, and a side, an angle, and a side. So reason being that they're congruent, side, angle, side. In number 4 it says, in this figure, which triangle is congruent to TSO? So it went from T to S to O. Well, T matches up with P, so it would be triangle P. So I went from T to S, so I need the 11, so this is P to O, and then finally to S, so triangle POS. Number 5, to prove that triangle BUP, so from 2 to 1 to none, when we're looking at the angles, congruent to triangle M to U to P, so 2 to 1 to none. Which triangle congruent postulate would you use? Well, I'm going from an angle, and now I have a shared side, so that's the reflexive property, so that would be angle, angle, side. In number 6, it says, given that triangle GAV is congruent to triangle VIN. So they're telling you they're congruent. That means that A matches up with I, so I must also be a right angle. What can you conclude? Well, we just said angle A has to be congruent to angle I because they're both right angles. I already know that AV is congruent to IN, so I don't need to repeat that. I know that GV is congruent to VN. I don't need to repeat that. What I do want to talk about is GA being congruent to VI. So I can say segment GA congruent to segment VI. And then finally, if you haven't already noticed, we have not said anything about angle G and angle V. So angle G is congruent to angle V. In problem number 7, it says, what would be a reason for the statement triangle LAP congruent to triangle OAN? So notice that they give me an angle. I have a side here, and then I also have vertical angles being congruent. So with that being said, I have an angle, and a side, so AAS. In problem number 8, it says, which postulate or theorem would you use to prove that BAT congruent to ABO? So it went from 2 to 1 to none, and then 2 to 1 to none. So I have an angle here, and then a shared side. So this would be angle, side, angle. In problem number 9, what is the correct congruent statement for the two triangles shown? So I want to say triangle 1, 2, 3 letters is congruent to the other triangle with 3 letters. So I'm going to start with S in the first one. S has no marking here, but X also has no marking. So I'm looking for one that has no marking here. I'm then going to go to O, so that has 1 marking. So the one that goes from no marking to 1 marking would be W to I because of the 1 marking on the side. So this would be WI. And then the last letter here is X. and the last letter here is N. So triangle socks congruent to triangle win. Number 10, it says in the figure, segment WA is perpendicular to segment HM. So WA perpendicular to HM, that means that I have a right angle there. And segment WH congruent to segment AH. Which of the following is true from the given information? So triangle WHM congruent to triangle AHM by SSA. Or that would be AAS if we rewrote it in a different order. Notice they only give me one angle. I don't know that W is congruent to A. I don't know that these two angles are congruent. So that is not the correct choice. Triangle WHM congruent to triangle AHM. So I do have a right angle, so HL could be a possibility. However, I do have a shared side here, and I don't know that my hypotenuse is congruent, so I can't use HL. Saying that it is not congruent, that's not true because I have a side, an angle, and a side, so the correct answer here is D. Looking at problems 11 through 15, it says use the following picture to name a chord. There is actually only one chord that you could use here. Remember, a chord does not go through the center, so we cannot use BQ. So the only chord that you could use here is BL, or you could write it as LB. A secant line. Remember, a secant line goes through the circle but not through the center. So there's three ways to name this specific line because that is your secant. You could name it as AB. You could name it as AL. Remember, you must have the arrows at the end. Or BL. And of course, you could switch these two letters around if you want to. A diameter. Remember, diameter goes from one endpoint to the other and must go through the center. So the diameter in this example is segment BQ. A tangent line. There are actually two tangent lines here. One of them you can name three different ways. So here is one of the tangent lines. You can call it CL. You could call it CP. Again, it must have the arrows. You could call it LP. And that is all describing the same line. So you only need one of them. Or you could choose the other tangent, which is down here, which is TQ. Again, must have the arrows. You could have these flipped as well. And then lastly, we have point of tangency. So that would be from our tangent line. That would be point L. Or it could be point Q. Number 16 says find the value of the missing length. Notice you have a circle here. You have a right triangle. So we can use the Pythagorean theorem. Across from the right angle is your hypotenuse. So I have 12 squared plus 16 squared all equal to the question mark squared. 12 squared is 144. 16 squared is 256, and that is all equal to the question mark squared. So 400 equals the question mark squared. Square root both sides. When you square root the right side, you're left with the question mark. The square root of 400 is 20. So the question mark is equal to 20. For questions 17 through 21, use the following diagram. Assume that QM and RN are diameters. So they're telling you that because you can use it as a semicircle. You could also use it as vertical angles. So the first thing that I like to do in these problems is put down all the angle measures before I even look over here at the question. So with that being said, here's congruent markings. So this angle must be 73 degrees. These are not vertical, so you cannot say that this angle here is 81 degrees. However, you know that from Q to R to M you have a semicircle because QM is the diameter. So if I take 180 minus 73, that gives me 107. So this is 107 degrees. You also know that from N to P to R, this is the diameter, so these three angles must add to 180. So I can take 81 plus 73, that gives me a total of 154, and now I want to subtract that from 180, and that will give me this angle here. So when I subtract, you're going to have to borrow here. So you get 26 degrees. So this is 26 degrees. So now I'm going to go ahead and answer the question. So it says, what is the measure of PQ, the arc? So it takes on the central angle, so that is 26 degrees. What is the measure of arc PR? So from P to R, that would be 26 plus 73 for a total of 99 degrees. What is the measure of Q to P to M? Q to P to M, that is 180 degrees because you have a semicircle there. What is the measure of N to R to M? So N to R to M, 360 degrees in a circle. And if I subtract off everything but the 73 degrees, you will have to borrow here. So when you borrow, 10 minus 3 is 7, 35 minus 7 is 28, so this is 287 degrees. What is the measure of PRQ? So P to R to Q, that would be 360 minus this 26 degree angle. Again, you'll have to borrow. So 10 minus 6 is 4, 35 minus 2 is 33, so this is 334 degrees. Last problem, number 22, it says find the measure of arc CE. So notice I have a diameter and it's intersecting a chord. It forms a right angle. So that means that CD is congruent to ED. So I'm going to take 9x and set it equal to 80 minus x. And now I want to solve for x. So I'm going to add x to both sides. Remember, there's a 1 in front of this, so 9 plus 1 is 10x, and that is all equal to 80. Divide both sides by 10, and you get that x is equal to 8. So now when I substitute in 8, 9 times 8 is 72 degrees. Since they are congruent, this is also 72 degrees, but the question is asking for this arc, so both of them together. So that's 72 plus 72, or 144 degrees.